Okay, so we have limited time together. Keep in mind that, well, I'll take any questions about anything from anywhere. Keep in mind that the review sheets focus your attention on what the expectation for the test will be. So that probably is our best thing to do since we do have limited time today. So, Brayden.
Are we allowed to ask one more question?
You can, but did you hear what I just said?
Yeah.
Okay, all right, I'm fine with it, I don't care.
4-7, section 5.
And you remember, I did post the answers to this, so it's all, oh, it's 4, question 5, I have a video posted.
Yeah, I lost it. I have the answer. I was so really. You just want to ask that a different time, like also.
Yeah, because, I mean, I'm not sure what to say. The angle okay, I relabeled the angles. Let's just look at the tiny little one at the bottom. I don't remember what I called that, but that tiny little angle at the bottom, what do I know about it? Its tangent is 2 over x. So if the tangent of that angle, I'll call it A. I don't know what I called it when I did it before, but the tangent of that angle is 2 over x, right? Yeah. So that means A is the angle whose tangent, A is the angle whose tangent is 2 over x. So if I knew this number, if I knew this was 15 or something, I would second tangent 15, and that would give me the measure of that angle, right?
Oh, yeah. I understand that.
All right, so who else has a question about something as we prepare? This chapter is got a lot of stuff in it, a lot of stuff. Okay, Sam.
Could you do number 3 on review 2?
This is going to have to be a calculator question. I don't think I marked that, or maybe I did, I don't know. But it's going to have to be a calculator question because when I solve this, it says the sine is -1/6. And if I don't have a calculator, the only angles I can do are things that say sine x equals √3/2, because that's a special one, or 1/2. That 1/6 is not in my, so I'm going to have to figure this out with a calculator. Now, this tells me a couple of things. It tells me I'm in radians. So I'm going to make sure my calculator's set in radians. And then it also tells me that I am looking all the way around. That's 1 revolution. So I'm allowed to look everywhere. Sometimes this is not that. Sometimes it's 0 to pi. Well, then you would only be looking up here. But that's all the way around. So now, where is the sine? All these are options. Where is the sine, which is y? Where is the sine a negative number?
Quadrant 3 or 4.
Quadrant 3 and quadrant 4. So my answers are going to be this angle and this angle. Those are going to be my answers. But before I can figure out what those are, I'm going to need my reference angle. So I'm already in radians, so second sine 1 divided by 6, oops, 1 divided by 6 is 0.17 basically.
But if it's negative,
I don't put the negative in because with a sign it's not going to be a big deal. It will give you a negative answer though, which isn't possible. So what you really want is just the size of that angle. The negative is already covered because you put it in the negative quadrants. So when you find the reference angle, you just need a positive value, okay? If you put a negative into a cosine, it's really going to screw you up. So it is best just to leave the negative out, find the reference angle, and then answer the question. So the answers are gonna be, the red one is gonna be pi plus 0.17. And the purple one is going to be 2 pi minus 0.17. Because all the way around would be 2 pi, but I didn't go this much. Okay, so then on my calculator, I can just get a number here and get a number here, and those would be my two answers. If the problem had been in degrees, everything would be exactly the same, except, I mean, obviously you'd be in degrees, so you'd have a different number here. But instead of doing pi plus the angle, it would be 180 plus the angle, and 360 minus the angle if we were in degrees.
Okay.
Okay?
Okay.
Who else?
Review 2, number 11.
11. Alright, so I'm finding the cosine. I know the cotangent is -3/2, and I know that I am between 0 and 3 pi over 2. So again, this is really, really important. This tells you where you're allowed to look. So I'm allowed to look here, or here, or here. That's where I'm allowed to look. But the cotangent has to be a negative number. Well, that rules out quadrant 1, right? Nothing is negative in quadrant 1. And what about down here, if it's a cotangent? Bronson?
Both the opposite and the adjacent are going to be negative.
So if it would be impossible to have, if I were down here in this quadrant, it would be impossible to have the adjacent be -3 and the opposite be +2. Wouldn't that be impossible? So it must, even though I had 3 options to start with, it really boils down to it's got to be quadrant 2. That's the only place that the positives and negatives line up within the options that I've been given. So the hypotenuse, that's going to be the square root of 13. And I'm going to say this one more time. When you do the Pythagorean theorem, it's a squared plus b squared equals c squared, and that must be the hypotenuse. Some of you mess that up because you just square whatever I give you and add them up. No, 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 no. Okay, so root 13. All right, now I want the cosine. What's the cosine of that angle? -3 over root 13, or -3 root 13 over 13 when I rationalize it. Okay. All right, who else has a question about something? You're all supposed to bring something today. Drew?
12 on the second review.
All right, 2 equations using 2 different functions. All right, this is clearly, the functions I'm going to use are sine and cosine because this is a sine and cosine shape. Remember what do tangents and cotangents look like? Squiggly lines? Okay, that's not what I have here. What do secants and cosecants look like? Parabolas. I don't have that. So this is a sine or a cosine. And I'm just putting in all the possible blanks there. Those are the numbers that I can put in to adjust the picture, to change the picture. This multiplies the height of the picture, multiplies the amplitude. Well, when I look at this, it looks like the amplitude is 1/3. So I'm just going to put a 1/3 there. When I look at that, has there been a vertical shift? No. The hills are the same amount above the x-axis as the valleys are below it. So there's no vertical shift. So you can either leave that blank, or since I have blanks, I'm going to put a 0 in there, but there is no vertical shift in this problem. When I look at what I drew, just the part I drew, does that look like a sine to you? I mean, what I drew? So I'm going to start with that. I'm going to think of it as a sine curve. And it is not starting where it's supposed to start. It's supposed to start at 0, the origin, but this one has been shifted to the left, pi over 5. So x plus pi over 5 in my sine equation. And then my period, that is the distance from beginning to end, is supposed to be 2 pi. What is the distance from beginning to end here?
6 pi over 5.
6 pi over 5. So my period is 6 pi over 5, start to finish. Do not be confused by that. I started at -1/5, I stopped at 1. That's 6/5, 1 1/5. So the period has been changed. And to change the period, we divide 2 pi by this number. That's how you modify the period. You put a number in here, and then 2 pi divided by that number gives you your period. So I'm working backwards. I know what my period is. I'm trying to figure out what that number is. So 6 pi n equals 10 pi. So n equals 10 pi over 6 pi, which is going to reduce to 5/3. So this number is a 5/3. In other words, if you had that equation, you would take 2 pi and divide it by 5/3 to find the period, right? And when you did that, it would come out to be 6 pi over 5. So there's your sine equation. Keep in mind that your cosine equation is going to have exactly the same numbers, except for this. Because if you're thinking of this as a cosine, you're not starting here, right? If you're thinking of it as a cosine, you would probably start up here. So what is that point? Pi over 10? So this is going to be x minus pi over 10. Okay? All right, what else? Yeah.
Could you do problem 1 on review number 1?
Okay, I have to do this with my calculator and without my calculator. Okay, so the first thing, I'm going to do it without a calculator first. And like all things mathematics, we start inside the parentheses. I'm going to draw a picture of that. That's an angle, folks. That's an inverse function. That's an angle. And what do I know about that angle? Well, I know it's in quadrant 1 because inverse cosecants can only be in 1 or 4. And since it's positive, it's got to be 1. So it's in quadrant 1, and its cosecant is 8/5, hypotenuse over opposite. So here we go with our Pythagorean theorem. This is going to be x squared plus 25 equals 64, right? So x squared equals, what is that? 39. Do you have the square root of 39? So now I've drawn a picture of the parentheses. So now I want the secant of that. What's the secant of that angle? 8 over root 39. So the secant is 8 root 39 over 39. Secant is hypotenuse over adjacent. And then I need to times that answer by 3. So that's going to be 24 root 39. Oh, actually, that's going to reduce, isn't it? When I times it by 3. Isn't it going to be 8 root 39 over 13? If I reduce it.
Why couldn't it be quadrant 2?
Because the inverse functions are only defined in specific quadrants. I gave you that list. You gotta know. Okay? Is cosecant positive in quadrant 2? Absolutely. But when you use this notation, you're not allowed to look at the whole coordinate plane. You're only allowed to look at specific quadrants. Any of the inverse functions with a positive number are going to be quadrant 1, period. It's only the negatives that float around. Okay, so that's the problem. This is called the exact answer. Anytime you ask for the exact answer, that means do it by hand. Now, how would you go about typing something like that on your calculator? Well, you have to really be thinking, because first of all, you don't have either one of these two buttons, right? So if I needed to type this in on my calculator, I would have to rethink it as the angle whose sine is 5/8. Would you agree that these two things are the same thing? So that's how I'm going to type it in on my calculator. I mean, that's how I'm going to get the angle on my calculator, right? Now, okay, so I got the angle. How do I get a secant on my calculator? 1 divided by cosine. So now I'm going to do 1 divided by the cosine of this angle. And then I will times it by 3, which basically just puts a 3 up there on the top. Okay, let's type that in. So 3 divided by cosine second sine. Now, just for fun, let's double check the decimal we got. I got 3.843.
Yep.
Double check that with this. And guess what? It better be the same thing. Somebody asked me yesterday, we did a problem like this yesterday in one of the other classes. They said, well, can't we, if we can do this by hand, can we just type that in to get the decimal? Will that give you the decimal? Yeah. So if you're asked to do that problem, and you don't know how to type it on your calculator, you can do it by hand, and then type your fraction in. Okay, who else? Ben.
20B underneath there.
Did you choose 20
C.
as in boy?
Yes.
Remember, I'm very old, you have to really speak up. All right, 20B, an airplane leaves an airport on a course of 190 degrees. So here's 190 degrees. Remember, I'm on a compass, and compasses are labeled differently than regular angles are labeled. At a speed of 354 miles an hour. After traveling an hour and 30 minutes, so an hour and a half at 354 would be what? How far? .531. So the length of this thing is 531. Okay. Now he's going to change course. So he's right here right now, but now he's going to change course. And now he's going to fly on a course of 280. So 280 would be like this right here. Zero, 90, 180, 270, so a little bit past that. Another hour at the same speed. So that one is going to be just 354. And now he's right here. What is the plane's bearing and distance from the airport? So here's the airport, right where it was in the beginning. And now the guy is right here, and we want to know how far he is. Now, we don't know how to deal with angle right triangles in this chapter. That's all going to change in a few days. That's all going to change. So my guess is that's a 90 right there, but I'm gonna figure it out because in the next chapter, you're going to have to be able to figure out that angle and it won't be 90. Okay, let's think about it. This is 190. Doesn't that make this skinny little one right here 10? And these I do two compasses. So here they are, these are parallel lines right here. These are north-south lines, parallel. That is a transversal. If that's 10, this is 10. Alternate interior angles. I already know this one's 10 because 280, I went 10 past 270. Well, this is a quadrant between my north and west. That's 90, so doesn't that have to be 80? Since that's 10. From 280 to 360 is another 80. So that is indeed a right angle, 10 plus 80. Again, in the next chapter, it will not be, because we'll learn how to deal with triangles that aren't right. But that is a right angle, which means that's a right triangle, which means I can find the hypotenuse by just doing the Pythagorean theorem. So that will give me his distance from the airport. And that distance is about 638.18 miles. That's his distance from the airport. Now I need his bearing from the airport. Okay, would you agree that it's going to be 190 plus whatever this angle is, I'll call it theta? That's going to be his bearing, right? Because the purple angle is his bearing. All right, so I need to find theta. Well, this is a right triangle. With regard to theta, isn't this opposite and adjacent? So the tangent of theta is 354 over 531. How do I find an angle like that? What do I have to type in on my calculator? Second tangent, the inverse tangent. So that's going to give me the purple angle, or actually the angle theta. Oh, wait a second, I got to make sure I'm in degrees. Yep, switch it over to degrees. Shoot, I haven't used that yet, right? Okay, so second tangent, 353 divided by 5. I got 33.69. So my bearing will be 190 plus 33.69, whatever that is when you add it together. Right? All right, Bronson?
What would bearing be if we were talking about like from the plane to the airport? Would we be able to find that with the information we had?
I don't know, but you would set the compass point here, right? And then you would be finding, I guess, that angle right there. Oh no, this angle, because we measure from due north. So it would be this angle right here you'd be looking for. Okay, what else do we have? Sarah?
Number 4A on page number 1.
On the area of the sector, that's called a sector, when you have a piece of pie cut out of a circle. And what do I know? I know this is 150 degrees, and I know the radius is 6. I don't know the area of that. Oh boy, this is not hard at all. This isn't hard at all. What's the area of the whole circle? Area of the whole circle is 36 pi. Pi r squared, 36 pi. I don't want the whole circle though, do I? What would I do if I wanted half the circle? I'd just divide that by 2 or multiply by half. Well, what fraction of the circle do I want? I don't want a half, I don't want a fourth. What fraction of the circle do I want?
36.
I want 150 3/60ths of the circle. Isn't that the fraction of the circle that I want? So 1536, which actually reduces even more, but it doesn't really matter because you can use your calculator, but 1536 would be, what, 5/12? So 5/12 of 36 pi. I got 15 pi. So the area of that is 15 pi. So don't make that more than it is. That's easy. That is easy. You just want part of the circle. All right, what else? Sir?
Can you do number 2, number 82?
10 on review 2. A wheel with a 15-inch radius is traveling 62 miles per hour. So I'm going to start with that. That's the beginning. That's what I know. And I eventually want to end up with revolutions per minute. Well, part of that's easy. I've got hours, I want minutes. So 1 hour is 60 minutes. I'll go ahead and take care of that. But here's the key. Talked about this over and over before. We're going from we have to somehow link a distance and a revolution. So we must remember that a revolution is a circumference. That's the key, because that's going to get you everything you need. So a revolution, one revolution, is a circumference. What is it's a 15-inch radius, so the circumference would be 30 pi inches. That's the key. A revolution is a circumference. So now I have revolutions per minute built into my problem. Isn't that what I wanted? Yep, it's all good, except I got all this extra junk in there. So I've got to take, let's see, I know 12 inches is 1 foot, and I know 5,280 feet is 1 mile. Will that take care of all my extraneous units that need to get rid of? I need to get rid of them. The inches are gone, the feet are gone, and the miles are gone. So that's going to be the answer to my question. Just be careful when you type it in. Remember, these are individual numbers. So either put the whole denominator in parentheses or divide by 3 individual numbers. So 62 times 12, 5,280, divided by 60, divided by 30, divided by 5. I got 694.68.
On the first one.
Jim looks at the top of the building and finds the angle elevation. So here's Jim looking at the top of the building, and the angle of elevation is 35. He moves 100 feet closer, so this is 100. And now his angle of elevation is 40. And we want to know the height of the building. Well, we've done problems like this before. Does this seem like one of those where we might need a system of equations? Because we really don't have too much stuff here. So I'm going to call this y. And looking at this triangle right here, the tangent of 40 equals x over y. Would you agree with that? The tangent of 40 equals x over y. And then looking at the whole triangle, the tangent of 35 equals x over y plus 100. So now I've got a system of equations, so I don't know, I just get x by itself and see what happens. So x equals y tan 40. And x equals, I'm going to distribute this, so y tan 35 plus 100 tan 35. Okay, so I can set those equal to each other. So y tan 40 equals y tan 35 plus 100 tan 35. Now I'm going to solve for y. So don't I need to have them on the same side of the equation? And I need to factor them out. So I'm running out of room, so I'm going to do that in one step. So I'm going to have y tan 40 minus tan 35 equal to 100 tan 35. So I put both of my y's on the same side of the equation, subtracted, and then factored out the y. So y is going to equal 100 tan 35 over tan 40 minus tan 35. Now, it would be a crying shame to do all that and then type it in wrong. Make sure when you type it in that you're putting that denominator in parentheses. All right. We should be in degrees. These are degrees. Which I think I am because I had to change it for the last problem. So 100 tan 35 divided by tan 40 minus tan 35. Okay, I got 504 for y. But now remember, you're not looking for y, you're looking for x. So come back over here, and what did we say x equal? Y times the tangent of 40. So all I have to do is take this on my calculator and multiply it by tan 40. And the answer to the problem is 423.02 feet. Because x equals y times tan 40. So once I had y, I just had to multiply by tan 40. Okay? All right. Now, here's the situation. I'm going to have you again. Is what, Thursday?
Yeah.
On Thursday,